Substances are identified by their properties as well as their composition. Color, melting point, and boiling point are physical properties. A physical property can be measured and observed without changing the composition or identity of a substance. For example, we can measure the melting point of ice by heating a block of ice and recording the temperature at which the ice is melted or converted into water. Water differs only from ice in its appearance, not in composition. It's still H2O. So this is a physical change. We can freeze the water to recover the original ice. Therefore, the melting point of a substance is a physical property. Similarly, when we say that helium gas is lighter than air, we're referring to a physical property. On the other hand, the statement, hydrogen gas burns in oxygen gas to form water, describes a chemical property of hydrogen. To observe this chemical property of hydrogen, we must carry out a chemical change, in this case, burning the hydrogen gas in oxygen. After the change, the original chemical substance, the hydrogen gas, will have vanished, and all that will be left is a different chemical substance, water. We cannot recover the hydrogen from the water by means of a physical change, like boiling or freezing. Every time we hard boil an egg, we bring about a chemical change. When subjected to a temperature of about 100 degrees Celsius, the yolk and the egg white undergo changes that alter not only their physical appearance, but their chemical makeup as well. When eaten, the egg is changed again by the substances in the body called enzymes. This digestive action is another example of a chemical change. What happens during digestion depends on the chemical properties of both the enzymes and the food. All measurable properties of matter fall into one of two additional categories, extensive properties and intensive properties. The measured value of an extensive property depends on how much matter is being considered. Mass, which is the quantity of matter in a given sample of a substance, is an extensive property. More matter means more mass. Values of the same extensive property can be added together. For example, 2 copper pennies will have a combined mass that is the sum of the masses of each penny. And the length of 2 tennis courts is the sum of the lengths of each tennis court. Volume, defined as length cubed, is another extensive property. The value of an extensive quantity depends on the amount of matter. The measured value of an intensive property does not depend on how much matter is being considered. Density, defined by the mass of an object divided by its volume, is an intensive property. So is temperature. Suppose that we have 2 beakers, each containing 100 milliliters of water at 25 degrees Celsius. If we combine them to give 200 milliliters of water in a larger beaker, the temperature of the combined quantities of water will still be 25 degrees Celsius, the same as it was in the 2 separate beakers. The density of the combined quantities of water will also be the same as the original quantities. So will the color. The temperature and the density of water do not depend on the amount of water present. Unlike mass, length, and volume, temperature and other intensive properties are not additive.